Okay, we're back. This is Math 200. We're looking at Chapter 2, 2.7, finishing off the Chapter 2 notes. We're on page 16 of the packet. Absolute value inequalities. Absolute value inequalities is what we're looking at now. So first, let's remind ourselves, what does absolute value mean? Absolute value is asking how far on a number line is this number from zero, whatever's inside of that absolute value sign. So if this were a number line and I was right here and this was zero right here, they're asking what distance is that. So whether it's negative, if I'm at -3, then it's 3 away from zero, +3. If I'm at +7, then it's 7 away from zero, all right? So that's what absolute value means. It's a distance from zero. So if you take the absolute value of a positive number, it's positive. If you take the absolute value of a negative number, it becomes positive. The only time that it isn't a positive value is if you take the absolute value of zero, right? The absolute value of zero is zero, which is not positive or negative. So let's look back up here. What can produce this as an answer? The absolute value of what gives you 7. The absolute value of what gives you 7. There's two answers. Well, one of them is 7. The absolute value of 7 is 7. Also, -7. The absolute value of -7 is 7. The distance from zero on a number line. So the positive and the negative of each are the same distance from zero. So now let's look at this problem. So when we're going to solve this problem, it's called a fancy word in math is an algorithm. An algorithm is a set of rules you follow to solve a problem. So this is the algorithm when you have the absolute value all by itself, you want it isolated, equals a number. You split it into two problems where you write it out just as it is, and then you write it out, but then you throw a negative for there. Now, why do I put I've had students say, wait, why do you go positive and negative with this number instead of positive and negative with that? Well, first of all, you could do it with that, but think, if I were taking this and saying, well, how do I get 7? Well, it could be 7 or -7. So what I'm doing is I'm setting this equal to, in this case, 4. And I'm setting this equal to -4, because if there was a 4 there, that would be it. If there was a -4 there, that would do it. All right? Now, if they are silly and they ask us for something like this, the absolute value of 3x plus 2 is equal to -9. You cannot take an absolute value and have it equal a negative number. And so that would just be the empty set, no solution. That's like a 0 with a big long line through it. That's known as the empty set, or no real solutions. Okay? Okay, so now, this is an OR problem. We just do it. -6 divided by 2, -1, or -5. Now be careful with that, because I've had students get those wrong because they get here, -1, and then they go, oh, okay, then it's going to be +1. Well, no, it's not, because there's a bunch of other stuff here that's in play. So it's not always just the positive and negative of the same number. Okay, you got to work out two separate little problems. And this would be really boring to graph, because we just put a dot on -1 and a dot on -5, and that would be it. So we usually don't graph equalities, equals, all right? So the absolute value of 2x minus 6 equals 4. So before you split up the band like this and do two different problems, first you have to get it isolated. So the absolute value of 2x is equal to 10. Now you split up the band. 2x equals 10, 2x equals -10. Divide by 2, x is equal to 5, or x is equal to -5. So this particular one did work out to be the positive and negative version of the same number. But it doesn't always do that. So make sure you examine carefully. How about this one? We got 7x, the absolute value of 7x equals 0. So if I split up the band, I would say 7x equals 0 or 7x equals, well, negative 0, but that's just negative 1 times 0, which is just 0. So x is equal to 0 or x is equal to 0. So these are not distinct answers. So we got basically the same answer twice because it was 0. That's that special case. Okay, let's squeak in number 4 here. We got 3x minus 2. The absolute value of quantity 3x minus 2 plus 8 equals 1. So again, we want to isolate this absolute value, so we subtract 8. And hold up there. This is it. You don't do that. You can't take the absolute value of something and have it equal a negative number. That is no real solution, or the empty set. I'll add the empty set also. So this is x is equal to the empty set. I think on the online program, that's how they want you to identify the answer. Okay? Okay, let's look at absolute value inequalities. So these were absolute value equations. These were zeros. Now we're going to do the same thing but with inequalities. And that's going to play back into our and or problems. Those compound inequalities or those other ones that were going on forever. Okay, so let's do that. So when you have an absolute value and a less than sign, that is an and problem. Like a compound inequality. And. So the way that I remember this was, when I first learned it, see how it's less than or less than or equal to? It's pointing this way. It's telling you, take this number and make a negative version of it on that end. And problems are a little easier than or problems, because you can always do them like this. Subtract 4 from all 3 sides. And we're done. Okay? If we want the interval notation of that, that's negative 10 to 2, not inclusive. If we wanted the graph of that, 4, 5, 6, 7, 8, 9, 10. 2. It's a parenthesis there, a parenthesis there, and then shaded in between. All right. It's a big B. So just like before, we don't start the problem until the absolute value is isolated. So we want to get this all by itself. So we subtract 6. And now it's an absolute value, less or equal to 1. So again, it's telling you, hey, take this number, add it over there. So, and now cover that up with your thumb if you're a little shaky. Add 3, and then uncover it, go, oh, third side, add 3. So from 2 to 4 inclusive, that is bracket. If we did the graph, look at how close the graph is to the interval notation. That would be a bracket right there, a bracket right there, and then shaded in between. All right. Or problems. On the last page, page 18, or problems, and problems are absolute value with a less than sign, or problems are absolute values with a greater than sign. So, or problems, it's pointing at the number. It's not pointing at the absolute value. And so this one we do like the equals to sign. We break it into two equations. X plus 2 is greater than or equal to 0, or x plus 2 is less than or equal to, well, negative 0, but remember, a negative 1 times 0 is still just 0. So then we solve these. X is greater than or equal to negative 2, or x is less than or equal to negative 2. So if we were to graph that, it would be greater than, so this way. And then it would be also less than from the same point, inclusive. So that way, so look, we've got the whole number line shaded in, including the negative 2. So that's negative infinity to infinity. Would be the interval notation of that. All right, let's get D. Oh, that one's a little tougher. Let's go up here. That one's got a fraction. All right, so we've got the absolute value. 7 plus x over 2 is greater than or equal to 4. So we're going to split this into two inequalities. 7 plus x over 2, or is greater than or equal to 4, or 7 plus x over 2 is less than or equal to, so we flip-flop the sign, and we make it negative. All right, and so let's do that. So then I'm dividing by 2. I don't want to have that. So let's multiply this side by 2 over 1. Let's multiply this side by 2 over 1, and look what happens. Those cancel. So I have 7 plus x is greater than or equal to 8. And I want to solve that. So x is greater than or equal to 1, or multiply by 2, those cancel. 7 plus x is less than or equal to negative 8. Minus 7, x is less than or equal to negative 15. So this is a little more typical of what an OR problem graph looks like. Where we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is a bracket shaded that way. And 1, that is a bracket shaded that way. And never the two shall meet. But so that's, remember, OR is combining all your stuff, but in this case, there's no overlap of your stuff. So it's all that and all that. All right, in interval notation, let's do interval notation off of that. So that's what, negative infinity to negative 15, inclusive, and then union 1 to positive infinity, like so. Okay, and we'll add the graph. Okay, excellent. That's it for chapter 2. I hope it's making sense.